as ANA goes towards 0, you can hear it kind of becoming a little bit fuzzier, a little bit more like a square wave. And as it gets more and more towards 0, you get more and more of those harmonics. And then here, you barely are able to hear it all. And then as it goes through 0, it flips the wave upside down. So this is more or less how a ring modulator works. So if I plug in that second input again, we get this lovely, kind of classic ring modulator kind of sound. Especially maybe if I switch to a triangle wave, less harmonics. Oop. That's that 60s sci-fi kind of sound we're all going for. So, a lot of the outputs from ANA at audio rate at least sound like a ring modulator. So if I show you the minimum, it's got a similar kind of attitude as the VCA maximum. Again, sounds pretty similar. VCA. So now we have magnitude. And magnitude is, I guess, a little bit more similar to like half of a wave folder. Alright, so magnitude gives you the difference between the two signals. Wow, that's really hard to see like that. Let's try something more like this. Alright, so we've got a static voltage again, and the sine wave. So this triangle wave isn't doing anything. As the static voltage goes towards 0, it will kind of bounce off of 0 and head in the other direction. So it's basically what's known as a difference rectifier. And what that means is that you're subtracting the two inputs and then you're sending it through a rectifier. And I apologize if I sort of am assuming a certain level of synthesis familiarity. We're at a modular synth shop. If any of these questions or terms that I'm referring to are confusing, I'm happy to go into more detail as to like what a rectifier does. So, for example, your rectifier just basically keeps voltages positive all the time. So in math, that would be like an absolute value function. So if we subtract two signals and take the rectified version of it, you're ending up with something that's actually like an octave up. So we've got our sine wave coming in, and you can see this kind of like bouncy sine wave going at twice the speed of the input. So if we listen to that, you can hear this kind of interesting octave doubling effect, like right around there. All right, that's our normal frequency. Here it is an octave up, and there it goes again. And it's quite lovely to hear at audio rate. It's just slightly phasing. It almost looks like a car or something, bouncing along. So I find this output to be really useful for feedback patches, because for example, if you run an LFO into ANA and you want to have one of the outputs plugged back into the LFO to frequency modulate it, a lot of times what you get is your LFO is at a low voltage, and so it's making the feedback of the LFO go slower. And then when it reaches a high voltage, it'll go faster. So what you end up with are these like long, low sections, and then as it goes up, it kind of blips really fast and then goes low again. And that isn't honestly very interesting to listen to. So if you have an LFO going in and the output is always made to be positive, then you're only making your LFO faster than how it originally would be, if that makes sense. Okay, so, oh hey, Eric Slappy's here. Now we can start.
Can you do me a favor? And
Yes.
We're live.
Oh, perfect.
15 minutes. Just go over the setup you have.
Okay, yeah.
Just for the
Hello, Internet Universe. My name is Eli from Mystic Circuits, and we are showing off our most recent module, ANA, which is an analog logic module. It takes in two inputs, which is currently the green sine wave input and the blue triangle wave input. And then the red signal is our output from ANA. We already went over a couple of outputs, so hopefully you caught some of that, but we are currently looking at the magnitude output, which, oops, all good. Yes. You might notice some schmutz on my modular. It's because I was doing video synthesis outside yesterday in the garden, and some dirt ended up on it. So smoke-free studio, but not necessarily dirt or planting soil free. And here we have Philip's password for his iPad. In case any of you Russian hackers are watching at home, please don't take over our stream. So, we've gone over all the, they're interesting, but these are sort of outputs that you can get from another module, potentially. Now let's go over some of the things you can't really get from another module. So, this one is called step. And step is a track and hold based on both of your inputs. So, the track and holds are funny because a lot of people understand sample and holds, but they kind of do and they kind of don't. So if I were to pause this for a moment, you can see boop, on our lovely Mordax data that we have a signal coming in, and sometimes it just kind of gets held for a moment as a staircase. But sometimes it's letting our original signal through. So in this case, I believe our sine wave is inverted. Maybe if it's nice to be able to see it like matching up with the input. So there we go. Pause. Okay, perfect. So you can see right here, we have our original signal going through. And then right here, it's deciding to make a little almost incision into our wave and hold it for whatever period of time it decides to do. Then here, we're back to our original signal. Here, we're holding again until it jumps back to the original signal down here. So a sample and hold will just give you those stair steps. It never lets the original signal through if it's designed correctly. So the nice thing about a track and hold is you can get these sort of strange combinations of both wiggly, fluctuating waves and static held voltage steps. And this is the basis for such famous random generators as the Wogglebug and the Surge Smooth Step Generator. So this output in particular is great at making pseudo-random sequences that will have portions of silence or like a static moment where the voltage is held, and then sometimes whatever you have coming through is allowed through. So you have your LFO, will kind of like solo for a minute and do a little bit of like arpeggios if you have it going into a quantizer. Then it'll hold it for a long portion of time in order to kind of add some breath to it. That's how I think of it anyways. So if we were to listen to it as an audio rate process, then we can hear a little bit of what it sounds like as a signal shaper. So you can see that as I increase the speed of the triangle wave, we get a higher sampling frequency. And the funny thing about ANA is it kind of decides what to do with sampling based on both of the inputs. So if one of the inputs is going at audio rate, you're going to get something similar to audio rate sampling. And if one of the inputs, like let's say if I plugged an LFO in instead, So a funny thing about ANA is that it's sort of like whatever speed you put things in at, you get them out at that speed as well. So even though one of our inputs is a really slow LFO, if the other input is audio, we're still going to get out audio. So you can see it's doing this bizarre wave shaping feature to it, function or whatever. I usually like to run into the offset instead with step. But if we run it back into audio rate, you get something similar to a downsampler. For those of you following at home, yes, everything that I've released so far is a downsampler. Alright, so now I will show you my favorite output, which is also the loudest. So I have to turn it down a little bit. Box. Box is a bipolar comparator. And what that means is that it makes a 3-level square wave. I'll turn this down while I explain it. So currently, we just have the sine wave going in, and then this knob is acting as a static voltage. So our wave the wave shaping isn't being modulated. So you'll notice here, we've got our sine wave, and then we have this square wave that has 3 values. So it has positive, 0, and negative. So if any of you are familiar with the Livewire audio frequency generator, it's one of the few VCOs that are made which lets you pulse width modulate the positive and negative portion of the wave separately. So that means you're kind of adding together 2 square waves and changing the width of each side independently. So this lets you do that with an arbitrary input. So if we watch and listen, as I change the offset voltage, you can see that we're pulse width modulating just the top portion. It flips, and then we're pulse width modulating just the bottom portion. And of course, if I change the other knob, it will also have a large effect. I really like right around there. It gives you these nice spiky waveforms based on the input. This is, of course, voltage controllable. If I plug in an LFO, bear with me while we buzz a little bit. There we go. It's got these nice sections too where it kind of like splits between 2 different states. So for example, here it's giving you the pulse width modulation of both sides, and then here it flips to that other square wave. Does some of its own stuff. Let's try putting in another LFO. If we do this guy, plug into the sum, so now we're taking our sine wave, we're putting it through the attenuverter, and we're adding a second wave to it with the sum input. So a second LFO is going into the sum, and it lets us have a little bit more of an effect over the wave shaping. So this is, of course, a sine wave. If we were to make a slightly more interesting wave, we might get some more compelling results. And maybe I'll just play you the input for a comparison. It's just not much going on, you know? Plug into box. All of a sudden we're in pulse width modulation paradise. So this input in particular is really great for processing audio, like of I have actually a drum set up. Let's listen to that. Bear with me for a moment. The best part of doing modular synth demos is everybody watching you repatch when it's not making any sound. So we do some of this, and then we have the Pico Drums coming in. Let's see what that sounds like. Take that out. Yeah, I use them with the Pico Drums quite a bit because I find that the signal is a little bit low on the Pico Drums, and running it through the box output of ANA will make anything that comes through into a -5 to 5 volt signal. So it all comes out a bit louder, which is lovely. And then of course you're able to change kind of the flavor of the distortion with this second input. Yeah. So that's handy. I could patch in some LFOs as well, and we could listen to what that sounds like. So ANA is audio rate, video rate, and DC coupled. So you can run a whole variety of things into it, and interesting stuff will happen. If we just listen to the output of Platts, now I'm going to take the step output off screen. There's a quantizer. Run it into that quantizer and run the quantizer back into Platts. Alright, let's see what that sounds like. Ooh, lovely. Try and catch some of the quantizer as well over here. Pardon the tentacles. So we've got that. This is a sequence that's being generated from 2 LFOs coming in from a pingable envelope generator. Now we're doing both the pitch and the gate sequencing all from our 2 envelopes. Gosh, I really wish I could show you the whole patch. Maybe if I back up a little bit. Oh, we're good. I think I just need to, yeah. So you can see these lights and see how it responds, right? So these 2 lights from our pingable envelope generator are going into ANA. Oh, I see. This light's covered up a little bit, but you can see kind of what it's doing over here. So if I make one side faster, it will affect the way that our sequence is generated. And if I mess with the attenuators, sometimes things happen. Then of course I can take the other outputs, run them into modulation. So I do the harmonic. And is going into, what is that? Morph. I'll take one of these and run it into timbre. And as we mess with the dials on ANA, it gives us a completely different behavior. And I believe I mentioned earlier, but the magnitude output in itself is quite useful for feedback with LFOs. So if I run something from magnitude into the division of our, let's do the other one actually, because this one is going into the track and hold input. So now we have a patch where ANA is being controlled by this LFO and is also controlling the LFO. So if I turn some of the dials, we'll get completely different sort of generative feedback kinds of behavior. And this is very much the sort of style that I personally make music in, but also that I intend for my modules to be well suited for, which is a sort of exploratory style of like, I have no idea what's going to happen, but when I turn this dial, it does something, and hopefully that something is musical. Yeah, sure. Thank you, Phil. Alright. So, whoa. Yeah, sure. So, I'll go quiet for a moment and just explain it one more time. Basically, we have our pingable envelope generator up here. Pingable envelope generator has two LFOs. Each LFO is going into ANA, and we have one LFO going into the main input on channel 1, so this is acting as an attenuator. Our second LFO is going into the sum input on channel 2, so this is acting as an offset. Then we have all 6 of our outputs going into plats. The step output, which is the track and hold, which gives you the sort of smooth step generator shapes, is going into this quantizer, which if I move the tentacle, you can see is sort of bouncing around sometimes when it's passing through the LFO, and then it'll stay static for a little while when the when ANA has basically decided to hold it still, which gives you this sort of contrast between the sections of the sequence where it's bouncing around a whole bunch or when it sort of takes a pause. And I find that to be similar to a lot of almost like jazz soloists, like with a breath instrument or a reed instrument, you have to stop to breathe, and it gives the audience a moment to pause and like digest what they were doing, as opposed to with string instruments, it's so easy to just wail on it as much as possible and do all these licks and scales and not really keep in mind that that can be oppressive to listen to. So in this case, ANA is doing the note sequencing based on both of your inputs being combined into this note sequence. It's also sending a trigger to plats in order to tell it when to activate the envelope. So if I make the envelope shorter, which is a little tough to do with one hand. Alright, so now we have little plucky envelopes coming from plats. I'll turn that up a tiny bit. And the last sort of ingredient in this patch is some feedback from the magnitude output rather, back into the speed or division input for the pingable envelope generator. So this makes it so that you can turn a knob on ANA, or two knobs, and it will change the way that the LFO and the processes of ANA are interacting. Yeah, any questions? I hope you're paying attention for the test later. Okay, so we've got LFOs going in. Let's do it with gates. So, as mentioned before, ANA, people always ask me how it's pronounced, and I keep going back and forth on it. So just pronounce it however you like. ANA or ANA? How does it speak to you? So we can do, I guess we could just use gates from the pingable envelope generator. As mentioned before, ANA is a logic module that works with continuous voltages, but it will also do logic on gates. And the funny thing about that is that it will actually work with a certain amount of voltage control. So if we do this, and then maybe plug into mag, some of you might be aware that in analog or fuzzy logic, the minimum of two signals is the AND of those two signals, and the maximum of two signals is the OR of two signals. So this whole module kind of got started by me thinking, well, if you can use these sorts of minimum maximum processes in order to do logic, then you can extend that to make something like an XOR, or something like that. Apologies if that's a little bit technical, but essentially we have AND, OR, and XOR all built into this module. So if we listen to ANA plugged into the Pico Drums, then we should be able to hear some of that. Yes, the level. Alright, so if I make this a bit faster, maybe tie these together. So we have one gate from the pingable envelope generator going into ANA, and then the second gate going at half the speed of the first gate. And unlike most logic modules, if you turn the knobs, it actually has an effect on the gates that come out. What effect they are can be kind of hard to determine. But what it means is that you can run in an LFO and modulate your gate sequence. So now I have a slow sine wave LFO going into input 1. And you can hear there's a little bit of variation to our gate sequence now. Could potentially use another output to trigger. Oh, we're already using an output for plats, so if we use that as a third drum. Oh, we were already listening to it. Perfect. Not entirely sure what's going on there. But yeah, we have static clocks coming in. You turn the knobs, and it changes up your sequence. So you can get some interesting stuff this way. Evolving gate sequences. Alright, I guess I could show ANA for video, but I think I'm going to wait on the video section until we have gone over the other stuff. So that's ANA. Now I'm going to show you Tree. Tree has not come out yet, unfortunately, but we are very close and working diligently on it. Tree is a sequential switch and a gate sequencer that works with binary. And most importantly, has rainbow lights. So you'll notice that rainbows are pretty important to us here at Mystic Circuits. We never skimp on an opportunity to add color to our modules. So in this case, we have a tempi, I'll make a little faster, going into the clock input. Nothing too special about that. You can see the sequence slowly tracing from top to bottom. In this case, because it's a bidirectional sequential switch. So you plug into this common node. If you plug a voltage output in here, that output will be routed to any one of these 8 outputs. So you can send that output to 8 different places. If you plug this into a voltage input, you're able to route 8 different signals into that input. If you plug nothing in here, this is tied to a high voltage, and all of these outputs act as gates. So it lets you do 3 different things with one module. In this case, you would basically be getting a gate sequence that would be sequentially triggering one thing at a time. Not super interesting. So if we listen on our Pico drum, this would be like beat 1 and beat 4 are going to trigger a drum. Yeah. All right. So you'll notice sometimes drums trigger when they're not supposed to. This is one of the things we're working on. If we plug into our reset input, then that's the only thing. It's going to be staying at 0, like a normal reset. Oh, I see. That's actually Platt's making sound. All right, so we have that. There's a direction input. So if we plug a gate in here, which is slower, you can see it kind of switching direction every time that output goes high. Cool. Now, the thing that makes this module interesting are these 3 inputs right here, which are known as the shift inputs. You can see our sequence is at position 1 up at the top. If I plug a gate into our shift by 1 input, the position of the sequence moves by 1 down the sequence. If we plug into shift by 2, the position of the sequence moves down by 2. And if we plug into shift by 4, we get gabber. Position of the sequence moves down by 4. Now, these all work in conjunction, so if we plug a different gate into all 3, we get this sort of evolving sequence which is completely determined by the inputs. And the nice thing about this is that you can run audio into one of these inputs, you can run an LFO into one of these inputs, you can run gates into one of these inputs. It'll always have an effect. So this is a static sequence that is actually repeating itself. Just takes a while to do so. And if we were to plug a clock in here, it actually shifts the entire sequence by whatever the position of the clock is. So if I were to take everything out, you can see the sequence is kind of moving down, but it's bouncing between each step that's like 4 steps away because we're driving this shift by 4 input. Plug it into shift by 1, see it kind of bounce along the sequence, but shifting by 1. Plug in all of these. We get some pretty funky beats that you wouldn't really be able to just sit there and program all of this. Well, I guess you could, but I don't have the patience for that. So I have 4 clock streams going in, and the nice thing about this clock is that it actually rotates the entire sequence. So if I plug in here, we have the same gate sequence going into our shift inputs, but sending it a clock changes the position of where those shift inputs are shifting from. I hope that makes sense. It'll shift in time to whatever you put into the shift input. So if I wanted to run an LFO into one of the shift inputs that's not tied to the clock, then you'll get things happening in another sort of speed. here now, it's a little bit untied from the grid. If I wanted to plug audio into that input, let's see what happens. Get some lovely fart drums. That's what we all got into Modular for. Ross knows. Yeah. So, let's try using it as a switch now. So, same pattern happening, but if we were to say plug 8 audio sources in, I get confused sometimes repatching all of the different parts, and then it's like, where did that part come from? Okay, so maybe plug our sawtooth to the input. Oh, I believe. All right. You've got to show everyone your password again.
Yeah. I trust them.
I do too. Thank you. All right, so now we've got 4 things plugged into Tree, making sound. I took a sawtooth from our 2HP VCO, put it into our Thomas Henry Zlob state variable filter. I'm a big fan of this filter. And I believe an output from Platts is also plugged in to the 4th input. And now you can see that we are crossfading, or not crossfading, we're switching between 4 different inputs, and it's still using the same sort of like pattern generation technique as we were getting before with the drums, except instead of sending out triggers to control drums, you're now switching between different audio sources. You can see as well that this LED right here is showing you the level of whatever is coming out of this output. So if we had it going in the other direction, this would be showing the voltage that was present at this output being routed to all of the other sections. And again, when we unplug, oh, it's actually showing a little bit of both. Oh, another nice thing about Tree, which unfortunately I can't show you today, is that Tree hosts Turing machine expanders. So at a certain point, there will be a voltages expander attached to this, which will let you use Tree for note sequencing as well as gate sequencing and sequential switching. Don't worry about it too much if you didn't follow that, but if you're familiar with the Turing machine expanders, Tree will be able to drive all of the Turing machine expanders, which means it will also be open source. All right. It's what basically the Turing machine expanders work by sending 8 gates from whatever is the host module into a variety of expanders that just do something with those 8 gates. So for example, voltages lets you mix the gates together in such a way as to make a voltage sequence out of them. Or switches, which is one of mine, controls 8 switches and then lets you mix down the sum of whichever switches are activated. Things of that nature. So I think that's good for Tree, unless anyone has any questions so far. Any? Yes.
I heard at the beginning. So is Tree bidirectional?
Tree is bidirectional.
Okay.
So you can use this either as an input or an output, and it'll be routed to all of these nodes either as inputs or outputs.
So it's like
It's 8 in, 1 out, or 1 in, 8 out. Yep.
Any idea on the availability of that?
So we have already done some production prototyping, and it's been at 95% ready for like a year now, basically. Like, it's been more or less ironing out a couple of last bugs concerning, you know, when there's a gate at this output, why am I getting triggers at this output, things of that nature. So far, so good. I'm doing another board revision to be ready for when I get back from NobCon. So hopefully at that point we'll be able to start beta testing the final version, but I'm hesitant to make promises because this is something that I was hoping would be ready a long time ago. But we already have panels for it, as you can see. We've got the panels, so as soon as the circuit is done, I'm going to get it on the press as fast as possible and hopefully just have it just never have a problem again. Tree also works for video, which is quite nice. Okay, so if that's all for Tree, I'll show you guys Portal, which is our fanciest upcoming module. Oh, okay. Oh, it looks like there's lock. I must have tapped it or something.
I locked it.
Okay.
Just now, where is your
Portal's right there. I'll take some of these out of the way. Maybe if we could also get the oscilloscope in the shot.
Oh yeah, no problem.
Tilt it up a little bit, thank you. Oh yeah, perfect. Ooh, very nice. Okay.
Good?
Yes, thank you. So port. Oh. Of course.
It works.
Okay. This actually works out nicely since I have to get Portal ready anyways.
Good, because it sounds good.
Okay, so we can hear Portal. Okay. But of course we all want to see Portal. That's the most important thing, is how these look. And Portal, it looks good. It looks evil. Essentially, Portal turns everything into industrial. So you have a sine wave in and a bunch of nasty garbage coming out.
Put book club on mute.
Okay. Rebooting again.
We'll probably get copyright stricken if we, yeah.
But yeah, sure.
There must be, yeah, okay. Yeah, I'll just make some annoying sounds with Portal, I guess. Okay, so this is what our input, if I was to do your guitar demo, right, this is our Telecaster 1958 US model with the baby blue finish, and this is what it sounds like through Portal. And, yeah, so it does a lot. Basically, Portal is similar to a wave folder, in that a wave folder, you'll sort of have your voltage, if we all imagine a voltage, right? And it's climbing up and up and up and up. And at a certain point, your voltage hits a threshold where it just sort of goes in the other direction, right? And so you're folding your wave back in on itself. With a wave wrapper, what happens is your voltage is going up and climbing, and then it hits that threshold and just jumps back down to zero. So if you imagine with a triangle wave, right? We've all got our triangle wave. We fold the top of the triangle wave in, it makes a triangle wave 1 octave up. If we have a sawtooth, we jump the sawtooth back down to zero right here. We have a sawtooth that's an octave up. I literally did this for a physics project in school. I did the physics of techno, and I had all the waveforms and stuff. It's so much better than an oscilloscope, you know? So if we have a sawtooth an octave up versus a triangle wave that we're folding to be an octave up, you can sort of imagine the difference in quality between a wave folder and a wave wrapper, sort of like being the difference in timbre between a triangle wave and a sawtooth. So, woo! All right, so we can actually hear it now. Thank you for bearing with us. Basically, we've got our somewhat, that's the sine wave. There we go. So we've got our sine wave in, going through Portal, and you can see here we're decreasing the amplitude of the sine wave, and as it sort of jumps up and up and up, oh, there we go. Now it's jumping back down to zero. And of course, doing so in a very chaotic way, which we like here at Mystic Circuits. So if we listen to this, you can hear this is right before the threshold where it starts to wrap around. That's one wrap. It's so far away. That's the wrap. Maybe actually if I pause it. Yeah, perfect. Okay. And I can point it out here. So you can see here, our wave hits the top threshold and then it just jumps back down to zero. Continues the wave, it hits the bottom threshold, jumps back down to zero. That basically makes a harmonic whenever you are, whenever your wave is wrapping around, hitting the threshold, it makes a new harmonic. So with a wave folder, you usually hear it adding harmonics in a beautiful way. With a wave wrapper, it just keeps adding harmonics in a real nasty way. Sure, that sounds pretty nice. I promise if anything sounds nice, it's an accident, and I apologize. So, another difference with Portal and a lot of wave wrappers, or wave folders, is that most wave folders work in stages, so each stage gives you one fold, or possibly 3 folds, depending. And then you kind of add stages together, that's what lets you get more folds. So a lot of wave folders can only do 9 to 12 folds, depending on how many stages they have. Portal works with feedback, so it gives you a different sort of technique for adding folds. So here, we've got, I don't know, a lot of wraps. If I switch this up into a higher range, at a certain point it sort of gives up. But if we go around here, you can see we're wrapping a really slow signal. That's like, if I change the range, that's probably about 100 wraps right there, and our wrap knob is only at about 9 o'clock, so you can hear like this is, you can't even hear the input, it's at such a low frequency, but as you're adding harmonics with Portal, you start to get into frequencies that are actually above the audio range, like it's a lot of harmonics, is what I'm trying to get at. Alright, so maybe we'll go back to low wrap mode, higher frequency. I'll show you some of the other functions. So, this track control basically controls how well the effect works. And at certain settings for track, it works somewhat stably, and at other settings, it just sort of does whatever the heck it wants. You can get quite a bit of a timbral shift from messing with the tracking control. This control is bias, which just literally adds a second waveform to the input, but when you modulate it, it will sort of mess with the way that the wrapping is happening. So if I add something in, we've got an LFO going in, and you can see even though it's very slow, it makes it difficult for the wave wrapper to sort of decide what point it's wrapping at. So it's just another way to add some chaos to the signal. And you can add in a second audio rate signal for some audio rate modulation. So now I'm running in a second oscillator to bias. It gives us some lovely tones. Sometimes if you run it in hot enough, you can get it to rectify like that, yeah. Which is nice because it adds in a little bit of the lower frequencies again. Like usually with the wave wrapper, you're just getting these like high screeches, right? If you have bias all the way to the side and it's adding in part of the fundamental frequency again, it sort of allows you to have this effect without compromising the sort of lower frequencies that are present in the signal. Sometimes it works on both sides, it depends. And then of course, what would a Mystic Circuits module be without voltage controlled feedback? So we have our feedback control here. Sometimes it sends things into ultrasound, but generally it just really dirties things up. And it has quite a large effect on the tracking control, especially. So I'd like all of you to keep in mind that this whole time the only input has been a sine wave. So it normally your sine wave just sounds like that. That's what a sine wave sounds like. Through Portal, it gets into all this nasty territory. But Portal doesn't just do nasty. It also has a somewhat more reserved output, the round output. And basically what round does is very similar to a bit crusher. Round will take your input and turn it into a bunch of stair steps by sort of approximating the level of the input to only a certain number of steps. So you can see here, right now, Portal is rounding our input to only 2 or 3 steps, and the distortion is all coming in from these squares that are sort of generated along the length of the signal. So this is similar to what you get from a bit crusher. And you can see that the effect actually goes away the more wraps that we're making. So it's a sort of interesting, like inverse sort of distortion than the wrap output. Of course, it responds to both the track and feedback controls. Bias will also have an effect. get out of it. Something I really like with this output though is, like, since up here the amount you're rounding by is so small that it's really similar to your normal input, if you run in an LFO to your bias control, it'll sort of confuse the process. In a really subtle way. Modulating the round amount also sounds quite lovely. Yes, I'm a big fan of this output. This is round, so the portal has, if I unplug, I guess it's probably hard to read, but we have wrap, round, and spike. And they're all related sort of portions of the circuit for the wave wrapper. So if I show you spike, spike is definitely the weirdest one. It basically makes a little spike every time a new wrap is generated on the wrap output. So with more wraps, you get something that's more similar to the input. With less wraps, you're getting a very quiet signal, but one that generates a trigger roughly once every cycle. This has a lot of influence from the track control and the feedback. Maybe I'll do this. It's interesting, using track almost sounds like a high-pass filter in this output. You can hear it, the signal kind of fading away into only higher frequencies, and then sort of coming back at lower tracking settings. So, Portal is a wacky wave wrapping distortion. It does a whole bunch of different things. Yes. Yes, actually, we can definitely try it on video. It's chaotic, but I've definitely gotten some pretty compelling stuff out of it for video. Let's see. I guess actually showing you Portal, it's a good time to show off the Spectra Mirror as well.
Is Portal in production?
Portal is not in production, but it is in prototyping. So we are getting production prototypes made, and we'll have a much better idea of what the final cost of the module is going to be at NopCon.
And is Spectra Mirror still in production?
Spectra Mirror is not still in production. Spectra Mirror, I sold out of the first batch and was ready to switch it over to surface mount assembly, which is what I do now with WMD. And sort of since then, some competitors had arrived on the market, and I feel like it could use a couple of maybe design updates and things of that nature. So I basically have decided at some point I'm going to make a Spectra Mirror Mark II, but for right now I'm focusing on getting out the newer modules and designs. And so right now Spectra Mirror is not in production, but at some point there will be a Mark II. Who knows when. But Spectra Mirror, if Portal is the wave wrapper harmonic generator, Spectra Mirror is a downsampler sort of way to get rid of harmonics. So we've got our sine wave, maybe get a signal with more harmonics, and as we add the Spectra Mirror effect, you can hear it sort of take away those higher frequencies. spectrometer is that it also uses a track and hold. So this makes it so that you can change the amount that the original signal is either being passed through or being held for a portion of time. So in this case, we have our tone, and the pulse width control for the internal oscillator is completely up, which means that we're only hearing the original input. As we decrease the pulse width control, oh, the frequency is high too. So pulse width up, no effect. Pulse width down, we start to get more and more of an effect, until eventually we get a DC voltage, which basically means it's just holding whatever the last voltage was when it got a clock. So an interesting thing about this is that we can modulate that, and it'll behave sort of like a VCA. A VCA that has a frequency set by the internal frequency of the oscillator. So with most downsamplers, what you're getting is basically only sampling, and you're able to change the frequency of the sampling, which basically lets you turn your input into a bunch of little stair steps. The nice thing about the spectrometer is that it lets you decide how much of that effect you're getting by controlling the pulse width of the internal oscillator. It also makes it so you get these cool kind of like tremolo effects at slower frequencies. So that goes all the way up there. If we were to modulate that yet again, you get this nice sort of alternation between downsampling and a weird kind of tremolo gatey effect. So that's the downsampler. Of course, voltage-controlled feedback on a Mystic Circuits module is a must. So here we have our feedback. Overall feedback control is set by the resonance knob. So this will give you sort of like resonant filter oscillation, similar to how a filter feedbacking will give you oscillation. Now, the feedback goes through a bipolar VCA, so negative feedback is actually like a more subtle kind of soft effect than your positive feedback, which is going to get loud. And you can hear, like with a low-pass filter that's resonating, it's really emphasizing that cutoff frequency. So this is it without any resonance. Much subtler effect. Like that. Let's see, we have 4 outputs on the spectrometer. This is an output for the internal clock, which tracks 1 volt per octave, so you can have it move in a similar fashion to whatever your input oscillator is. Sample and hold output is the output we were just listening to. VCA is just going, the sample and hold output basically going through the bipolar VCA that's in the resonance circuit. And then we have Morph. And Morph gives you access to some strange phase canceling effects. So if we give Morph a listen, in the middle, Morph doesn't have any effect. We're just listening to our normal input. To the left, Morph will subtract your sample and hold sound from the input and basically give you what I've termed a high-pass sampler, which basically means that you're phase canceling the downsampled output with the input. In other words, it gives you a high-pass filter that has the downsampler sort of effect. this has that downsampling sort of grittiness with all of the bottom end removed. An interesting effect. If we turn Morph all the way to the right, what we have is the sum of the downsampled effect and the normal input, which basically lets you do downsampling without actually destroying your original audio. Another lovely thing about Portal is that you can run in an external clock. I'm going to plug into the sample and hold now. And we do this. And now I have a micro braids plugged into the external clock. And I'm using that oscillator to control the sampling frequency. The nice thing about that is that when I change the timbre or the wave, it actually changes the sound of the downsampler. So right now I'm not actually changing the frequency of the micro braids, just the timbre and color, in order to sort of change the quality of our downsampling effect. Also, Portal and Portal and Spectrometer work together quite well, because Portal makes harmonics and the Spectrometer takes them away. So if we do some of this, oh, that's right. Okay, we've got this guy going here, and then we've got this guy going here. And then we've got our input. Alright, so flats is still the input. We control the amount of wave wrapping. And then Portal kind of chills that wave out. You can hear it almost sounds like a filter with all these harmonics. That's probably the last thing to show with Portal and Spectrometer, unless anyone has any questions. Yes, no, yes, perfect, okay. I've been working on some stuff for the Nebula, which is the qubit module, and they have asked me to create some pure data patches for it. Basically, the Nebula is able to run other sorts of sounds that you've designed yourself. So maybe I could show a bit of that before we switch over to video. Not quite yet.
Okay.
Yeah. Oh, thank you.
Nebula.
All right, looking good. Yeah, so this is the Qubit Nebula, which is not my module, but which I have been doing some new designs for. So normally the Nebula is a granular synthesis module, but with the ability to reprogram it using pure data, you're able to get quite a bit of other sorts of functionality out of it. So for example, this patch is a drum machine. If I plug in here, all right. Okay, so that's clearly our bass drum. We have controls for the pitch. We have controls for the pitch envelope and pitch envelope amount. We have control for the amplitude envelope. This is the brightness drum. This is some distortion on the drum. This adds non-linearity, which is a bit difficult to hear at a lower frequency like this. Yeah. Okay, so this adds non-linearity. Basically makes it into gobbledygook, but with a little bit, it sounds very nice. Pull this back. A little less gabber. Okay, so the thing about this module is that, or rather this drum machine setup, is that all of the drums are sharing the same settings. So if I increase the amplitude envelope for the bass drum, then it also increases the amplitude envelope for the snare. But we can lock in one of the drums when we decide that we've liked it, and it's no longer able to be modulated. So if I take a listen here, this is our snare drum. So let's just say, for the sake of argument, that I like the way this bass drum sounds. So I go into our alternate function, and now you can see, as I'm changing the speed, or rather the pitch of the hi-hat, the pitch of the snare, we're not having any effect on the bass drum. In fact, none of these knobs are having any effect on the bass drum. So it lets me go through the different sounds, kind of decide what I like. I've decided that I don't like having the snare be that fast. And now, okay, I like this snare. Maybe I'll make it a little snappier, actually. Snappier and brighter. So we've locked that snare. Now I'm going to add in a hi-hat. Hi-hat, again, shares the controls with all four of the other drum machines. I can get it to a setting that I like. Both of these inputs affect the hi-hat, but this trigger is the short hi-hat and this one's the long one. So maybe if I'll make it only happen every once in a while. Yeah, that's better. You make them higher pitched. I'm going to make this happen less often as well. last gate is going to the FM synth. So the FM synth gives us control over the harmonics, the amount of FM, brightness, forget what this does, I think it's a distortion, and decay amount. So we've locked in all of our other drums. We could literally just modulate this one last drum and have all of the rest of them stay still. So now we have LFOs going into several parameters for the FM drum. All of the other drums are staying put. If I wanted to, let's say, unlock the bass drum, now we're getting modulation on just the bass drum and the FM voice. Another nice thing about this drum setup is the speed knob is one of 4 preset effects. So this is like a DJ style mixer where we can high pass, filter both outputs. Oh, I figured I should mention that one output is just the bass drum and the other output is everything else, to let you sort of be able to, I find that that's the most useful for mixing, at least if you're only going to be able to do stereo. But we have our high pass filter on one side and then low pass on the other. For DJ style mixing, we have 4 other effects. So I believe that this should be the down sampling. That sounds like it's still filtering. Yeah. So we have down sampling, similar to the DJ style mixer. It's down sampling on this side, and then high pass sampling on this side, similar to how it worked on the spectrum mirror. So you can get a little bit of glitch that way. I have a third mode, which is a compander of sorts. So on the left, the amplitude envelope of each drum will be subtracted from the overall amount. On the right, it's added. With some extra beat. And then the last effect I just added actually is not an audio effect, but it's an effect on the incoming gates. So on the left, we are randomly subtracting gates, and the amount of randomness is determined by the position of the knob. So here we're removing all of the incoming gates. We're slowly increasing the probability that a gate will be added until around here, when we're getting all of them added. And then on the right, we're randomly ratcheting. So there we go. So we're getting random ratchets, and the ratcheting amount is also random. It's basically, as you go further right, the likelihood of ratcheting is increased, as well as the speed at which it'll ratchet. So if I just do all the way, you can hear this is randomly deciding which direction to ratchet it. And of course, the best way to do this is to modulate it. So if we modulate speed on the left, it'll add some space to our sequence, and on the right, it'll add some ratcheting. So you can hear with a static sequence, we're still getting a lot of variation in the patterns sounds that it generates. I'm just going to unlock all of the drums so you can do that as well. The nice thing about this is that it only grabs the parameters when you trigger it. So if you're sending in modulation and triggering your drums at different times, they're all going to have different settings. Alright, so that's it for the drum machine. That should be ready, I'm hoping, around KnobCon. Just have to clean up some of the patch and stuff like that. Any questions about that before I move on to the next thing?
It just loads up on the SD card?
Yeah, so if you dump the pure data patches onto this USB drive, then it will automatically load them at start. So you don't have to do any fancy programming or anything like that to get this. It'll be hosted on the Qubit website as soon as it's done.
What's it called? If it's pure data patch?
Yeah, I'm guessing it's a drum patch, yeah. So
Drum Boy?
Drum Boy, yes, something like that. I'm sure nobody would be upset with me for that, just since there's already a little drummer boy out there. Call it little drummer girl. Okay, so we've heard that, and I have one last pure data patch to show, which hopefully is this one. Colorful lights, very important at Mystic Circuits. Let's see. It's not it. Sometimes you just have to guess. It's always interesting now in these days when modules have screens and computers behind them and stuff. You're like, oh, my module crashed. How often does that happen? You got to blow on the cartridge and stuff. All right. So we got... No sound. My favorite song. Well, might not be able to. No, I don't think it's the mixer. I just was literally sending sound out, so this is probably my pure data patch not loading correctly. Oh well, I was real excited to show it to you guys. I'm going to try one more thing, and if that doesn't work, we'll switch to something else. I think that's it. That's not it. Okay, never mind. So, I have one new thing to show, which has not been revealed before. Some of you noticed when you came in that we were playing some video modular synthesis on the screen. And that's because we're about to release a video module. Well, famous last words, about to release. But we have begun designs on our first video module called the PF Arculator. For those of you who don't know, PFR stands for Punk Fucking Rock. And that's because this module is a bit of a departure from the perfectly stable, incredibly well-designed modules that you might find from a company such as LZX. This one lets you get something a little bit grittier. So, Phil, if we could switch to the video whenever you're ready. We have 4 oscillators, each one with their own frequency control, frequency range, which switches between vertical, horizontal, and LFO, vertical lines and horizontal lines, and I'll show that in a minute. There's a control for sync, a control for flipping the direction. Okay, so you can see we have vertical lines. The spacing of the vertical lines is set by the frequency of the oscillator. And you can already see it's a little bit jagged, but that's okay. That's what we're going for. So if I have one oscillator making vertical lines and another oscillator making horizontal lines, and I flip the horizontal, I put the horizontal line oscillator into the flip, let's see what we get. We get these weird little graph shapes. And the spacing of the horizontal lines, again, is set by the frequency of that oscillator. So if we modulate the horizontal with a diamond, or in this case a circle, we can get some real nifty shapes out of it. Like that. This is the kind of thing that the PF oscillator excels at, is weirdness. So while I can't exactly explain to you what the flip is going to do every time, it gives you a lot of strange options. If we plug that circle into our anarchy input, we get some weird circle-shaped static. Let's try doing it faster. Huh? Lots of strange checkerboard shapes. Maybe we can... Yes, this is just the PF oscillator and the visual cortex, giving it all of the sync information and the modulation for the diamond and stuff like that. Yeah. This is a 2-module patch, yes. But of course the PF oscillator is a quad oscillator, so it has a little bit of flexibility as far as how you're going to cross-patch everything. Let's look at, so each oscillator has 2 outputs, which I've basically dubbed hard and soft because they're not exactly square waves or triangle waves, but this is the soft output from that same patch, and you can see as we lower the frequency that it sort of smudges the edges of the lines, whereas the hard output won't do anything like that. Maybe if we do something like this. It's interesting because the soft output is actually much more stable than the hard output, and you get some flickering, but you don't get the sort of jagged lines that you do in the other case. Now, if I were to do this in color and then modulate the flip, we can get some nifty stuff. And of course, it's very nice for processing LZX modules. If we run a prismatic ray, which is the LZX video oscillator, into the flip input, we can use it as almost like a distortion on the LZX module. So the LZX is what's giving us these triangles that I'm playing with now, and then the PF oscillator is what's giving you those kind of stripes that flip in and out of it. And if we were to patch into the feed input, it would actually literally just give you video filtering on the input. We can do all kinds of lovely things with it. Let's see what happens when we desynchronize it. You get some weird kind of bouncing around, sort of. Yeah. So we have our PFR oscillator and our prismatic ray controlling each other. As I mentioned before, ANA does quite well with video, and I'll tell you why. It's because we have 6 outputs that are all derived from the same inputs. So if we plug in 3 of those outputs, we have RGB. Did it disconnect? Okay. Okay, so right around here, I'm only touching the control knobs for ANA, and it's sort of giving us different sections that intersect between the 2 waves. So maybe I'll take out the frequency modulation and, ooh, gonna move this for a moment. We'll do our sync for horizontal lines. So the PFR oscillator is doing horizontal, and the prismatic ray is doing vertical lines. And if we sort of toy with the settings on ANA, we can get all these strange sort of intersecting patterns based on both of them. And because it's controlling red, green, and blue, all from the same control, you can do some cool sort of colorizing things. So if I run an LFO into ANA,
What's going into ANA right now?
right now we have a horizontal bar from the PFR oscillator and a vertical bar from the prismatic ray. So this LFO is controlling ANA. I can set the amount with the onboard attenuator, and you can kind of see that as the LFO changes all of the outputs simultaneously, you're getting different mixtures of color. You can, of course, mess with which outputs you're listening to. So this is the step output, which sometimes is a little unruly, but it can give you some really interesting kind of, I'll take out the modulation. Step is now controlling the blue, and if you do it just right, you can get these interesting kind of decision-making problems that ANA runs into, where it can't quite decide which input it wants to follow. It's a little more interesting with a bit of a shape to it, so I'll run a diamond into the prismatic ray. Can get some interesting sorts of distortions on the signal from our video oscillators. So my setup for video at home is usually 2 oscillators going into ANA and ANA going into the visual cortex. And then I'll have all 6 outputs from ANA going into the 6 RGB inputs from the visual cortex. And you can crossfade between them and do some interesting stuff that way. So I can try the other 3 going in here. I realize it would be ideal for you to be able to see what I'm doing, but with video synths, unless you're a little familiar, it's all going to be gobbledygook anyways. So now we're able to crossfade between 3 outputs of ANA and the other 3, so you can see there's a kind of relation to them. Yeah, that's the kind of stuff I like to get with the step output. Yeah. So this is ANA for video. I'll show off tree for video now.
Before you unpatch it,
Yes.
it seems like the portal module would be pretty cool with the video.
Yeah, let's look at Portal. Portal is a little
Harmonics.
Yes. All right. Well, there we go. Let's listen to Portal for video. Let's see. So we have prismatic ray going into Portal, and then we have Portal going into the black and white input. And if we do some
Constantly searching.
it doesn't like that sometimes. Okay. Yes, of course. I'm not sure that the video is ready. Oh. Yes, I am having an effect, but not the effect that I was expecting. So, oh, here we go. Yeah, alright, so that's the roundout for... This is Portal. It's round output processing vertical lines coming from the prismatic ray. So if we kind of soften those a little bit. And now we are adding harmonics. You can see it kind of shifted the lines to be a little bit closer, but it's a little difficult to tell. If I do a diamond into the frequency modulation, when you're looking at the screen, you sometimes don't realize you're not actually touching the module. So this is the wrap on a set of lines, and you can see this around here. You're sort of getting what the input would look like around there. Yeah, so this is more or less what the input looks like, and this is what it looks like through Portal. I quite like the round output for video. It gives you these nice stripes that are all kind of related to your input.
Kind of makes your video look like it's being run through a broken photocopier.
The photocopier would be a good name for a video module. Yeah, something like that, where it's, yeah, the broken photocopier effect. With a slower speed, it does look a little bit more logical, but yeah, right there, you're getting something that almost looks like it's being filtered or something like that. And then you get these big bars across the middle, which can't really decide what they're doing. And some static and stuff like that. The spike output will also give you something. Especially because video is so fast, the spikes are actually moving at roughly the speed of the input. Yeah, so Portal is a pretty good distortion for video as well. A little bit temperamental. but I'm sure once I've messed with it more, it'll become clear what I'm doing wrong with it. Let's try running in one of the PF oscillators into it as well. So now I'm modulating round with a vertical line. I mean a horizontal line, and that's what's giving us like the bar in the middle, bars on the side and stuff. Maybe we can do another horizontal line. Yeah, so this is all modulation from the PF oscillator. Now I'm running the PF oscillator into tracking. Looks kind of like a bunch of mouths. Yeah. Anything else I should try with Portal?
Well, the next one.
The tree?
No, the one that removes the harmonics.
Oh, spectrum mirror. I haven't actually gotten a lot of great stuff out of spectrum mirror, but I bet if I run an oscillator in, we look at the sample and hold. Oh, that is a good idea, actually, yeah. Okay. Say that again?
Will the trees run at video rate?
Yes. Yeah, that was what I was... That's what I'm going to show next. I think that would make it the only video rate sequential switch, unless LZX made one in the Expedition series that I was not around for. So, if we do something like this, maybe? Here, I'm going to use the PF oscillator is now running into the external clock on the spectrum mirror. And so these horizontal lines that you're seeing are in fact from the spectrum mirror. In fact, I'm going to get rid of Portal in this just so we can see what it's actually doing. So, wow, alright, yeah, I guess we can get some video stuff out of the spectrum mirror. Something I have not done before. Yeah, it's kind of cool. It kind of turns your quilt into more of a boxy kind of lines. It just it smudges little bits of it. So yeah, so it's the diamond going through a the prismatic ray is making this sort of diamond shape. So if I were to do that, that's what's going in. And then the spectrum mirror is kind of flattening out these portions right here where it's deciding to do its sampling. And if I change the frequency of the PF oscillator, which is providing the vertical lines, that's what's giving us this effect. Maybe I could run prismatic ray into the flip for the PF oscillator, and now we've got something real weird. Yeah, wow, thanks for suggesting that. Alright, I'm gonna do tree now. So if we look at tree, what I'm going to do is plug a bunch of outputs from the prismatic ray into tree. Okay, so right now we are clocking tree with a PF oscillator, and I'm going to reset it to the frame so that hopefully it won't jump around. Alright, there's a little bit of jumping, but basically all of the inputs to tree are different inputs from the prismatic ray. I realize I'm doing this in black and white, and I'm like, what am I thinking? Obviously we need colors. So prismatic ray is making those yellow bars, and tree is switching between them. I might even be able to reset tree with the diamond. We do something like this. Yeah, so tree gives you these lovely blocky shapes coming from whatever your input is. Maybe I can use the last prismatic ray output, and we'll plug it into flip on our clock. So the prismatic ray is now also influencing the clock of the sequential switch. And you see you get those like pixelated kind of things going on. So you could do, you know, disco dance floors, stained glass windows, that sort of thing. And it's really nice when it gets to one of those states like right around there where it can't quite decide what it wants to do.
Can you see the controller?
Yeah. So I'm taking an LFO and I'm plugging it into the multiply on the prismatic ray. So now we're getting a bit of voltage control over the amount of pixelation which is coming from tree. Right now the prismatic ray, I believe, yeah, it's just squares, but if we plug a diamond into the frequency modulation, we'll get a different sort of effect. Maybe I'll unplug some of these and plug them in somewhere else. Yeah, so in this case, the prismatic ray is both the input to tree and it's modulating the flip input on one of the oscillators for the PF oscillator. And you can get some wild stuff with it. So I guess that means that all three of my new modules work with video, but the PF oscillator is the first one where I intentionally designed it to be useful for video as opposed to just having it be a happy accident that it looked interesting with video. And I've talked with Lars about this from LZX. I'm not going to be claiming that they're LZX compatible because that requires all of these modules to work within the 0 to 1 volt range, which would obviously make it difficult to use for audio. And also I can't promise that you can like put in an image from a camera and it's going to look perfectly like the image that you took out, but I would say that all of these are pretty useful for video nonetheless. Yeah. I didn't think to show you guys the 0 HP modules. I think that's the last thing that I've got that's interesting for us. So I know it's hard to see from over there, but I have these tiny passive modules called 0 HP. They basically let you take a utility out of your case, put it outside. It's passive, floating, doesn't take any power or space in the synth, and we have a whole variety of utilities. So
You have one that you can pass around?
yes, of course. Here.
suggestion. They're cool to touch.
Yes, of course. It's much different than like, hey, can you see this over here? Come up and take a look. Yeah. So we have so far the low pass gate is what we're passing around. There's an alternate version of that called the low pass VCA, which doesn't do any of the, or rather the Vactrol VCA, which doesn't do any of the filtering that you would get from a low pass gate. Both of them are Vactrol based modules which let you put in a gate to control the amplitude of your sound, and of course with a Vactrol it gives you a nice little bit of sludge on both the attack and the decay so that it sounds like an envelope without having to use an envelope. We also have a VCA which works at audio rate, so if you put in a gate it's going to sound like a normal VCA that you're controlling with a gate. Everything will turn on and off immediately. If you put in a snappy envelope, it'll give you a snappy envelope, whereas a Vactrol module will kind of sludge everything to make your envelope last much longer. We have a filter module, also based on the same chip as the VCA module, so you can do audio rate filter modulation. And our newest 0HP is an envelope, which can be both a envelope follower. So if you plug in an audio source like a drum loop or somebody talking, you'll get a voltage which corresponds to the amplitude of your source. So you can use it to extract voltage out of a drum, let's say, and then you're increasing the pitch of your oscillator when your drum is hitting, things along that nature. It also lets you patch in a gate and then you get a normal envelope out of it. So if I were to show you the VCA, there we go. All right. So this is our VCA, and you can hear it doing some amplitude modulation. As it goes slower, it makes these nice little pings. I could also plug it into an envelope, and we would get something a little more like that. You can hear a really snappy exponential envelope will give you a really snappy output. If I were to plug in the Vactrol VCA in comparison, you would be able to hear that, in all likelihood, that snappy envelope is now kind of sludged out to be much longer. If I just plug in that trigger, we get these nice little pings. Maybe I'll do a slightly longer trigger. Yeah, so you can hear, even though we're driving it with a gate, it doesn't sound like a gate. It sounds like it has a little bit of an envelope to it. That's the magic of Vactrols, and that's why a lot of musicians like them. I could also show the envelope really quickly. Yeah, what's up?
So, did you 3D print the thing around the Vactrol? That black stuff?
Yes, the Vactrol enclosure is 3D printed, and I actually have a 3D printed case that I'm prototyping for the 0HPs that I brought with me. So at the moment, the 0HPs kind of sit on an acrylic backing. The top of the 0HP is exposed, which I'm not concerned about, but a lot of other people have been like, I'm not buying that thing. Gonna put my $1,000 synth around your exposed circuit board. But in my opinion, it's safe. I've talked to other people who think it's safe. So The idea is to make these 3D printed cases, which will go around it. I'm currently getting a quote for a mold, and the nice thing about the 0HPs is that they're all the same exact form factor. So I don't have to get a different mold for each module. I can just stick it in here, put on the case, and now it's protected from all sides. Hypothetically, people have talked to me about maybe doing like magnets inside so that you can attach them together. And I get other people who are like, I wish that my 0HP could go and be mounted in the synth. And I'm like, that seems counterintuitive to me, but I might end up doing something about it just to satisfy those folks who want to have it behind a panel. Anyways, this is the envelope. And we're currently driving it with the same gate that we did before. The nice thing about the envelope is when there's no voltage present, it's at its longest decay. So if we run a voltage into it, the envelope shortens. And if we run an LFO into it, we can hear that we're getting voltage control over the envelope's release time. I'm trying to think, I could do something coming from the Pico Drums, potentially. Oh, another nice thing about the envelope is that the input is multed. So if we wanted to hear the Pico Drums, I don't have to use another mult. Let's see. So you can hear now whenever that bass drum is triggered that our oscillator is also going through. And now the amplitude of our oscillator is being controlled by the sound from both drums. It's annoying, but it's a little bit easier to show if I plug it into the pitch. So right now, oh, that's right, it's also coming from the LFO. Okay, so this is with no modulation. You can hear that the drums are sort of activating that pitch envelope, and when both of the drums are on, it's a higher pitch envelope because it's a louder signal. As I modulate the release time, you're getting that kind of like quieting and increasing of the pitch envelope modulation. So you can get some pretty interesting sorts of one sound controlling another sound kind of behavior coming from this. 0HP envelope is ready to go. I just need to build them when I get back to town. And then, of course, the long part is making the video. So, famous last words, 0HP envelope will be released soon. I think that's everything. I don't know if there's any questions. If you folks want to just come up and mess around with the video synth and talk to me directly and ask any questions, I'm happy to do that as well. Thanks a lot for having me.
Never mind. So if you could just give us a quick listing of the available modules and then what's coming up, just to kind of summarize everything up, that would be cool. Thank you very much, by the way. That was really great.
Thank you to Phil and to Modular 8 for having me. Oh, okay, yes.
What is
Vert. Oh my gosh, I didn't even talk about Vert. Oh, all right. Well, yeah. Would it be possible to get the iPad turned, the iPad stream? Okay. Yes. I didn't even